Well, hello there, this is Ron, and this is the intro video for Mechanics of Materials in the spring of 2017. And the purpose of this video is just to take a quick look at the class planner and then at the syllabus. To get to the syllabus and the class planner, if you go to the wiki and go to the Mechanics of Materials page, scroll all the way down to the bottom and you will find documents. Down there are the reflections, the describe, a blank describe sheet, and then a copy of the class planner, that's this, and a copy of the syllabus, and we'll get to that in a minute. So here is the class planner, and I've got 13 hours planned. We will work together to make sure that we get to that 13 hours. Early in the semester here, we will take a look at a calendar and make sure that everything gets accounted for and planned. The videos are to be watched before class, and so we haven't even had day one yet, and you should be watching this video on the syllabus and class planner. Now, I'm going to point out here that there's also a statics and shear and moment diagram refresher. So in this course, there's an expectation entering it that you can do statics, and by that I particularly mean 2D equilibrium of an object. So in Mechanics of Materials, of all the statics competencies, 2D equilibrium of an object is important, and everybody who should have had statics, 2D equilibrium of a beam is what I'm talking about. And then, of course, off of that comes shear and moment diagrams. The one other competence that's expected when you enter this course is being able to do moment of inertia. Now, if you would like a refresher, if you go to the videos on the wiki at the bottom, you will find refresher videos for shear and moment diagrams and for area moment of inertia. So if you don't remember that, I've got a couple of nice videos there that you can watch, and you should watch those before day one. All right, so what else is on this class planner? Each of the videos that are to be watched, they are on the wiki, the days, the class activities, and we'll spend a couple of class periods on axial stress and loading and deflection, bending, stress, loading, and deflection, shear, stress, loading, and deflection, torsional, stress, loading, and deflection. So the course really just has those four things: axial, bending, shear, and torsion. We'll take a quick peek at something called stress transformation at the end. I've got the reflections identified here, and if you take a look at those, they are in the document at the bottom of the wiki. There's describe homework every day. There are problems from the textbook every day. And then this is called retention practice. I want you to be practicing being able to describe these things to yourselves. They come from statics, and they're essential for an engineer. These things all end up on the FE exam. They all end up in our end of the semester exams. So there it is. One more note, that this stuff up here is assigned on the day of the class. So day one, this stuff gets assigned to be done for day two. So the videos get done before the class, the homework gets done after the class to be brought to the next class. All right, there we go, class planner. Here's the syllabus. Well, we've got Mechanics of Materials, Spring 2017. The outcomes of any IRE competency are there, and that's really that you can identify, describe, and apply the fundamental principles. And the fundamental principles are highlighted in yellow. They are axial, bending, shear, torsional, and for each one of those, loading, stress, and deflection, and then stress transformation. So those things in yellow there, those are the biggies. Those are the ones that you should be contemplating for your end of the semester fundamental principles exam. We'll get a chance to apply them in problems. We'll get a chance to apply them in a DLA. So what's expected of you? I want you to be here every day, fully engaged. You need to enter with an understanding of equilibrium, centroids, moment of inertia, shear moment diagrams, and the difference between external and internal forces, though we'll spend some time on that in the beginning. I want you to learn inside and outside of class. For every hour we're together, you should be spending 2 hours on your own. And you've got to practice encoding your knowledge so that you can come back and get it later. All right, page 2 of the syllabus, the deliverables, and the grading. Got 1,000 points, 300 for the exam, 300 for the DLA, 50 for the notes and problems, 150 for the reflections, 150 for the describes, and 50 for your engagement of learning. And I'll use the traditional IRE scale of 0, 1, 2, 3, 4, and 5. All right, there's the syllabus. So in closing, I want you to have watched this video before we start. I want you to contemplate your abilities in shear and moment diagrams. And if you feel a little rusty, go and watch the videos at the bottom of the wiki, bottom of the mom page of the wiki, and then also for calculating area moment of inertia. So let's see, today's Tuesday, and I'll have this posted tomorrow on Wednesday. That's when you should be watching the video, and we'll get together Thursday morning for mechanics and materials in the seminar room. See you there.